Good morning children. In today's class we are proceeding with pair of straight lines, some challenging problems of this exercise, especially equation of the bisectors. Question number 14. Show that the equation represents a pair of parallel straight lines. Find the distance between them. As we compare the given equation with the general second degree equation, A is 9, 2h is minus 24, h is minus 12, 2g is minus 12, g is minus 6, b is 16, 2f is 16, f is 8, c is minus 12. To check parallel, the condition is h square equals ab. H square minus 12 the whole square is 144. AB, A is 9, B is 16, 9 into 16 is 144. They are equal, represent that the given lines are parallel. To find the distance between them, we need the separate equations, for which let us consider x square, xy and y square term. 9x square minus 24xy plus 16y square. As we factorize 9 into 16, 144. I want minus 24, so it is minus 12 into 12. As I factorize 9x square minus 12xy plus 16y square. Combining first two and next two. In these two, 3x is common, taking which we get 3x minus 4y minus 12 and 16, 4 common, y and y square, y common, taking which I get 3x minus 4y. Now, I get 3x minus 4y into 3x minus 4y. This is the usual way of factorization. But whenever I know they are parallel lines, without even factorizing, you can directly write, if it is 9x square, I will get the square root 3x. If it is 16y square, I get the square root 4y. They are parallel. In the middle, I have minus symbol. Then I will put minus. If the middle term is plus, I will put plus. Because they are parallel, I will have the same factor again and again. To get the constants, introduce L to the first factor and M to the second factor. So I have 3x minus 4y plus L into 3x minus 4y plus m equal to 0. Call it as equation number 2. The given equation let us call number 1. Now we need to compare 1 and 2. For what all? Coefficient of x, coefficient of y, also constant. Whenever they are parallel lines, we need to compare the constant also. How to get coefficient of x? It is x from the first bracket, constant from the second. Constant from the first, x from the second. X, constant, constant, x. So what is my equation? 3 into m plus 3 into L equals, the coefficient of x is minus 12. To get coefficient of y, y from first bracket, constant from second, constant from first, y from second. So my equation is minus 4m minus 4l equals, y coefficient here is 16. Constant. How to get constant? In both the brackets, I will take only the constant. Here L, here M. So constant into constant equals to constant over here minus 12. Call the equations the same because Here I cancel 3, I get m plus l is minus 4. Here I cancel minus 4, I get m plus l is minus 4. So whenever we are in parallel straight lines, coefficient of x and y will give me same equation. So call that equation as number 3. Constant, as I compare, let me call it as number 4. From here, what is m? I can say m is minus 12 by L. Substitute this in third equation. What is third equation? M plus L is minus 4. M is minus 12 by L plus L is minus 4. Cross multiplying by L, minus 12, L into L, L square, minus 4 into L. Bringing it to the same side, L square plus 4L minus 12 equals to 0. Factorizing this, minus 12, I need plus 4. The two numbers are 6 and 2. Plus 6 minus 4. So what are the two factors that I get? L plus 6 into L minus 2, 0, or L is equal to minus 6 and 2. Put these values in M and get what is the relevant M value. When L is minus 6, M is equal to minus 12 by L. That is minus 12 by minus 6. I get 2. When L is equal to 2, M is equal to minus 12 by 2, that is minus 6. As we get L and M values, let us put them back in second equation. 3x minus 4y, L value minus 6 into 3x minus 4y plus M value 2 equal to 0. If I put 2 here, minus 6 will come. So any one equation will do. So what are the separate equations? Let us write each bracket 0 separately. 3x minus 4y minus 6, 0. 3x minus 4y plus 2 equal to 0. My question is to find the distance between the parallel lines. So distance between parallel lines. What formula we have learnt? Modulus of C1 minus C2 by root of A square plus B square. Here C1 is minus 6, C2 is 2 divided by root of A, B. A is 3 square, B is minus 4 square. When I take the modulus, write it as positive 8 by 9 plus 16, 25, square root is 5. So what is my answer? The distance between the two parallel lines is 8 by 5 and hence the problem. Question number 15, the same as the previous problem. Show that the equation represents pair of parallel straight lines. Find the distance between them. Try it yourself and check your answer. As we compare, A is 4, 2H is 4, B is 1, 2G is minus 6, 2F is minus 3, C is minus 4. Since given it is parallel, check H square equal to AB. H square equal to AB tells us the lines are parallel. To find the separate equations, consider the first three terms. 4x square plus 4xy plus y square. Factorizing 4 into 1, 4. We need 4 again. The only factors are 2 and 2. As I factorize, I get 2x plus y into 2x plus y. The other way, whenever I know they are parallel lines, just write square root. 4x square root is 2x. Y square root is y. In between plus symbol tells me I will put plus. Parallel tells the same factor again. Introduce L in the first factor and M in the second factor. So we get 2x plus y plus L into 2x plus y plus m equals 0. As we compare the given equation and the factors product, let us compare coefficient of x, y and constant. X, how to get it? X from the first bracket, constant from the second. 2 into m. Constant from the first and x from the second, L into 2, equals x coefficient is minus 6. Similarly, y coefficient, y from the first, constant from the second, 1 into m. Constant from the first, y from the second, L into 1. Do not write x or y, we need only the coefficients. Coefficient here for y is minus 3. As we know, parallel lines give us same equation as we cancel. So this and this one and the same, call it as number 3. Constants, when I compare L into m is minus 4. From here, m is minus 4 by L. Putting m back in third equation, cross multiplying, we get L value is minus 4 and 1. Once I know L value, substitute. M is equal to minus 4 by L. As we check, L is minus 4, m will be 1, or L is 1, m will be minus 4. So, because they are parallel, we get the same answer. Consider any two values, L as minus 4 and m as 1. So, this I substitute in second, I get the separate equations like this. Now, my question is distance between the parallel lines. So, this will be A, this will be B, and this will be C1, and this will be C2. Substituting in the formula, modulus of C1 minus C2 by root of A square plus B square. And simplifying, we get the distance between the parallel lines is root 5 units. Question number 16. Prove that one of the straight lines given by ax square plus 2hxy plus by square equal to 0 will bisect the angle between the coordinate axes if a plus b the whole square equals 4h square. Ax square plus 2hxy plus by square equal to 0 represents pair of straight lines through the origin. So let us consider the red dotted line for the pair of straight lines. Given, it bisects the angle between the coordinate axes. X and y axis are the coordinate axis. Angle between x and y is 90. If it bisects 90 by 2, so the line will make 45 with x-axis. In that case, slope of the line will be m1, that is tan 45, that is 1. Suppose the line bisects in this way. Now, again the angle is 45 only because between x dash and y it is 90. When it bisects, it is 45 again. But it is not simply 45 with the x-axis. With a positive direction of x-axis, it is 90 plus 45. So, I will say the slope will be tan of 90 plus 45. In that case, 90 comes change. In second quadrant, tan is negative. My answer is minus 1. So, slope can be either plus 1 or minus 1 for one particular bisector. Now, if m1 is 1, let me substitute in the condition for slopes. m1 plus m2 is minus 2h by b, m1, m2 is a by b. As I take m1 is 1, equation 1 gives me 1 plus m2 is minus 2h by b or m2 is minus 2h by b minus 1. Substituting in second equation, m1 is 1, m2 is minus 2h by b minus 1 equals to a by b. Taking LCM, it is minus 2h minus b by b equals a by b. Cancelling b, we get minus 2h equals a plus b. Call it as condition number 3. If m1 is minus 1, the same pattern. First equation gives minus 1 plus m2 is minus 2h by b, or m2 equals minus 2h by b plus 1. Second equation, m1 is minus 1, m2 is minus 2h by b plus 1. As I multiply, it is 2h by b minus 1 equals a by b. Taking LCM, 2h minus b equals a by b. Cancelling b, we get 2h equals a plus b. Call it as number 4. Now, let us see 3 and 4. Third equation tells a plus b is minus 2h. Fourth equation tells a plus b is 2h. So, together I will say a plus b is plus or minus 2h, or squaring we arrive at the result a plus b the whole square is 4h square, and that is the expected result. Question number 17. If the pair of straight lines x square minus 2k xy minus y square equal to 0 bisect the angle between x square minus 2l xy minus y square equal to 0, show that the latter pair also bisects the angle between the former. We are given two pairs. Call them as 1 and 2. What is equation of bisectors? We know the formula x square minus y square by a minus b equals xy by h. To apply the formula, let us write the equation. So here we get the bisectors as this equation. So let us write the bisectors. We know the equation x square minus 2lxy minus y square equal to 0. As I compare a value 1, 2h is minus 2l, so h is equal to minus l, b value minus 1. As I substitute x square minus y square by a minus b, 1 minus of minus 1 equals xy by h, h is minus l. As I simplify, I get x square minus y square by 2 equals xy by minus l, or x square minus y square equals minus 2 by l xy. Call it as third equation. We know 1 and 3 are identical because we are given 1 is the bisectors of 2. So here we have attained the bisector equation, but given 1 is the bisectors. So let me compare 1 and 3. X square same, minus y square same. Here I have minus 2k xy, here I have 2 by l xy to the same side. So as I compare this xy coefficient, I get minus 2k equals 2 by l, or I will say 2 and 2 cancels, k equals minus 1 by l. Now what we need to show actually, the latter pair also bisects the angle between the former. So how to write the bisectors of equation number 1? As I compare ax square plus 2hxy plus by square equal to 0 with the given equation, a value 1, 2 same, xy same, h is equal to minus k, and b value minus 1. Let me substitute in the bisectors. X square minus y square by a minus b equals xy by h. As I substitute, it is x square minus y square by 1 minus of minus 1 equals xy by minus k. Or I get x square minus y square by 1 plus 1 is 2 equals xy by minus k. Already I know what is k from here. Let me substitute. X square minus y square by 2 equals xy by minus into k value is minus 1 by L. As I cross multiply, x square minus y square is 2xy into minus and minus cancels, reciprocating, it is L. Or I get x square minus y square minus 2lxy equal to 0. This is the second equation. I started doing bisectors of 1. I arrived at the second equation. Hence the problem. So as I do bisectors of 1, I arrived at equation 2. So we will say second equation bisects the first equation, or I will say the latter pair bisects the angle between the former. Hence we conclude that the latter pair bisects the angle between the former. Let us quickly rough through the problem. Given two equations, two pairs are given, call this as 1 and this as 2. Given this equation, bisectors of this equation. So let me write bisectors of this equation. I arrive at some answer. But bisectors are already given as 1. So whatever answer I arrived here as 3, let me compare with the first equation and I arrive at k value. Now I want to show the second equation bisects the first pair. So let us write what are the angle bisectors of the first pair of equations. As I derive the angle bisectors, I arrive at second equation. So we conclude the latter pair bisects the angle between the former pair. Question number 18, we are learning a new technique, say homogenizing. Straight lines joining the origin to the points of intersection of a pair of lines and a linear equation are at right angles. Given from the origin, see there is no constant here. So we try to make it as homogeneous, that is having same degree. Because it is pair of straight lines, we try to achieve the degree 2. How to get it? From the second linear equation, I get 3x minus 2y equals to 1. The given straight lines 3x square plus 5xy minus 3y square plus these two, I can write 2x plus 3y into 1 equal to 0. Instead of 1, I can substitute this to homogenize. So I get 3x square 5xy minus 3y square plus 2x plus 3y into 3x minus 2y equals to 0. Instead of this 1, I am substituting 3x minus 2y. Such technique we call homogenizing. Now see, every term has degree 2. Here the degree 1, here the degree 1. When I multiply, add the degree, so every term will have degree 2. Let us simplify this. It is 3x square plus 5xy minus 3y square plus 2x into 3x, 2x into 2y, 3y into 3x, 3y into minus 2y equals to 0. Or we get 3x square plus 6x square, 9x square. 5xy minus 4xy plus xy. Minus 3y square minus 6y square minus 9y square. Every term is done equal to 0. Now, this I compare with ax square plus 2hxy plus by square equal to 0. I get a equals 9 and b equals minus 9. So, a plus b equal to 0 implies the lines are at right angles. The question is, we need to show they are at right angles. So, we have shown a plus b equal to 0, and so we declare the lines are at right angles. The usual way of doing is, whenever I see points of intersection, I must try to solve the two equations. From here, get what is y, put it back in this equation, I get some second degree equation in x, solve. So, I will get the 2 points. Once I get the 2 points, with origin, you drop the slopes of the two lines, show m1, m2 equal to minus 1. So, it's a big procedure. Instead, we use the technique of homogenizing the second degree equation where it becomes linear. Multiply with this linear equation so that it is entirely becoming a second degree equation, from which I get a and b value. A plus b 0 will immediately imply the lines are at right angles.